Developing autonomous driving systems for cars requires many miles of testing and data analysis. According to RAND Corporation, to ensure an accident rate of 20% lower than that of humans, it would take 100 cars in real driving environments, 24 hours a day, at 40 km an hour on average, for 500 years. Will there be roads in 500 years? To try to reduce deadlines, Porsche Engineering is developing an analysis and data collection system based on game engine technology, a framework on which video games were initially developed and which is currently also used for other functions, such as gathering virtual driving data. The aim is to develop advanced autonomous driving systems in shorter periods of time. Clara Marina Martinez, an engineering doctor who works in Porsche Engineering, explains the details of this work. First, she talks about her company for about 5 minutes, and then she focuses on game engine and simulation.
This presentation is Porsche Engineering. We are talking today about digital testing of automated driving functions. I am Clara Marina Martinez. I am developer engineer in virtual ADAS testing. As mentioned, we will talk briefly about Porsche Engineering and Porsche Engineering Group in the Porsche AG. You might already listen to the news, but we celebrate in April our 90-year birthday. As Porsche Engineering, we continue the philosophy of the original Porsche workshop in Stuttgart 90 years ago of developing the vehicle technology of the future car. That's what we do still today. We of course focus on our customer and we develop for our customer, but always thinking in the future. What is the future nowadays is electromobility, but also the keyword digitalization. So we are today focusing mostly on the intelligent connected vehicle on the future. And that we do, and we are proud to say that Porsche Engineering is becoming a tech company with main focus on digitalization technologies. That we do with our 1,500 employees that are all spread all over the world. We are actually quite an international group. 60% of these colleagues are focusing only on e-mobility and digitalization, and we have 450 software specialists that focus on these digitalization topics. These, of course, don't focus only in Germany. We have, as mentioned, 11 different sites. Germany is still our main headquarters, but we are also over Europe in Italy, the Czech Republic and Romania, and of course a very strategic position in China. If I go quickly through our main stations, you know, maybe you are familiar with the development center in Weissach. That's also our headquarters. We have also 2 other offices in Germany, Münster, where my colleague Julia sits, not far away from Weissach. And I myself live in Bietigheim-Bissingen, also here in Germany, in the area of Stuttgart. But particularly in my case, I work very, very close with our colleagues in Cluj-Napoca. There we have 50% of the PEVATeC team, and there is a really good location for software development. We call it the Silicon Valley of Europe. They're really good specialists in software. Timișoara was briefly opened, also in Romania, very close to university, and that's also the case of the first opening of Prague and Ostrava. There were locations that started very close to innovation, research, and university, and ended up in very solid locations in Czech Republic, for instance. We are very proud also of our NATO Technical Center, where we test in real tests with customers. Also nowadays, for highly automated driving, we've started developing some new testing strategies, combining virtual and real testing. And last but not least, we have our office in Shanghai, which is our Chinese market phone place location, which allows us to better understand the market needs and the function special requirements. So that's all about Porsche Engineering Group. Today, before we go into the technical part, I would like to talk briefly about game engines. Maybe this term is familiar to you. This picture was used this year for the game engine Unreal to release their last version, Unreal 5. You may notice how good they have been. I mean, video games are nowadays so realistic. They have the textures, the materials. But what about these pictures? What do you think? Is it real? Is it virtual? No answer?
I'm going to guess it's virtual because it's only the questions.
Exactly, because I'm talking about game engines. It wouldn't make any sense. Yeah, correct. But it looks quite nice, right? The same thing we use also to develop virtual simulation for ADAS testing. But let's talk briefly about game engines. What is that actually? The most currently used game engines are Unreal, as mentioned, and Unity. There are other game engines, but in Porsche Engineering we focus on these two, which are the ones that are driving more development also in directions out of video gaming. And a game engine for us is not just a tool, it's actually a platform that provides many different tools within it. It's obvious it has a graphic engine, but it also has a physics engine. It has a collision system, animation, sound system, and many other functions that combining big libraries that we can use, we can adapt, we can extend for automotive applications. In this case, we can use them combined with other tools and traditional simulation tools to develop an environment for virtual ADAS testing. But there are other applications. For instance, we can use it to visualize the end product even without it is created. The materials, the reflections, even in the interior, the fingerprints when we touch somewhere. We use it as well on our workshops with the help of a tablet or a HoloLens. We can overlay in augmented reality or even create a full car where nothing is there. And that way we can work on site. For example, South Germany, Stuttgart can work with Leipzig together on the same project without meeting. That means we don't need to drive, we don't need the time to travel. And also in the Corona times it's quite good because we don't actually need to have physical contact. And this way colleagues can do trainings, not from locations, and also work together on the same projects. But as promised, today we are talking about highly automated driving and how we develop that virtually. That we do with our simulation environment PEVATeC. This is the Porsche Engineering Virtual ADAS Testing Center. What it is exactly, actually this PEVATeC simulation environment is not just a tool, it's actually a platform. We make use of the game engine technology, but we also combine other tools and their own developed software on our side. And we can divide it in more or less 6 different main points. The first one is the scene and scenario. What is scene for us is the static world. I mean, we have a road, we have lane marking, we have traffic lights and so on. This is all static and it's not moving, and that would create my scene, my 3D world that will be through the game engine visualized. But of course I need movement. The highly automated driver needs to drive somewhere. That's what we model through the scenario. We have our Porsche, our vehicle, but we also have other vehicles around that move somehow and create some maneuvers that will challenge my ADAS feature. That could be cars, that could be bicycles, animals, pedestrians, whatever you want. So when we have this dynamic and static environment, we also need, of course, to test the feature in my car. That would be my Porsche vehicle. In Porsche Engineering, we've developed vehicle dynamics models for years already that really reproduce the actual vehicle dynamics of the real car. That means I can drive my Cayenne and I will have the same lateral dynamics, the same longitudinal dynamics, so that I can test comfort in simulation, braking distance, and so on. Last but not least, is very important for highly automated driving, sensors. I need radars, cameras, lidar, perception, and so on. This part we also simulate here. And by that I don't just mean just in the simulation environment have some interface. What we simulate here is exactly the same format, the same interface of each of the cars that we had driving outside. What does it imply? When I'm driving a vehicle and I'm testing a function in the car, it will have a connection to the communication bus on the vehicle and we'll get some information from the sensors. Each car has a different platform. Each customer will bring a different car. What we do is reproduce virtually exactly the same interface so that when we test virtual the function or real, there is actually no difference. The function doesn't know that it's in virtual environment or in the car. That allows us to go directly to the real prototype without having to adapt or convert any of the signals. So this part is all trying to duplicate the real world in virtual, but we can do a lot more. In the virtual world, we can test much more, much quicker, and much efficiently. That we do with test automation. We have a scenario, we have parameters that we can change speed, change distance to other vehicle, change a car by a truck, and so on. That we can do automatically and generate lots and lots of kilometers that we need to evaluate my ADAS function. And we can evaluate them using the KPIs in order to identify through these huge amount of kilometers which are the important ones, which are corner cases, which one challenged my function, did my function improve in the last release or not, that we evaluate through KPIs. So this is all happening in the virtual world, but we also work very close to the real world. We simulate all our test cases before we actually go outside so that we can preview of whether the test case makes sense or we want to make some changes before we actually get the real car, the colleagues, and do the driving, saving time and cost, obviously. And we do the other way around. When we test, for example, in an auto technical center, we get the recordings and we play back in simulation, as we also have virtualized the auto technical center. That means I can reproduce exactly what I dropped there, and I can analyze better the data, see where the function didn't perform and the reasons for that, make small variations, and also for us as simulation guys, we can improve the simulation learning of how the real world react, how the sensors react to specific conditions. That we do in point number 5, resimulation. Where is this all happening? I mean, you can think about we are located internationally in many different locations, doing development through different sites. We do that through the cloud. And also our colleagues from software development can access the simulation environment through the cloud so that they are not dependent on their hardware. When they have a very heavy simulation to execute, they can do it remotely and get the results quicker so that they don't need to have very high performance computers to do that. I brought today an example of a function that we are currently developing. The simulation environment will be on the left side. On the right side, I have the visualization of my function in real time. This function receives camera geometry, camera objects, radar geometries, and objects. That means the simulation through the camera can see, so the function can see where are the lane marking. This is not a copy of that. This is actually camera geometry interpretation of the real world. And then we approach another car and we will see 2 objects, respective camera and radar. This is happening in real time. It's fully virtual. The function is on the repository where we do the development. After the release, 1 second later, we can just directly test it in simulation, see the results. Are we happy or not? Do we improve it? Or we go directly to the car and do the same testing? That happens all simultaneously.